Okay, welcome back everybody. I hope you had a good weekend. So today is March 30th, 2020. Okay, and we will be talking about section 2.2, which is about graphs of equations. So remember, last time we talked a little bit about just how to plot graphs on the coordinate axis, finding the distance between 2 points, seeing if a triangle is a right triangle by checking it if it satisfied the Pythagorean theorem. And we also learned how to find the midpoint. Okay? So today we're going to learn how to graph equations and some other things about graphing equations. Okay. So when you're graphing equations, you're always going to have, or in this section, you're always going to have two variables, and rather than just one, a couple ordered pairs with points, you're going to have infinitely many points, coordinate points, that satisfy that equation. Okay, so the first example I'd like to talk about is sketch, and I'll outline the process too. Let's see if I can make this a little bit. Sketch the graph of y equals x squared minus 3. Okay, and we're just going to go from -3 to 3. So a good way to do this is just to pick some numbers for x. Okay, so we'll make like a little table here. So we got x in this column, and then we can write y equals x squared minus 3 here. Okay, and then we can write our ordered pair that we get over here, the point that we're going to need to graph. Right. Okay, so let's just pick some whole numbers here, some integers, or integers between -3 and 3. Okay, so I did -3 to 3. And now we're just going to continue, we're just going to see what for this x value, if x is equal to -3 or any of these values here, what would the y value be based on our equation? Okay, so if I do -3, you get -3 squared minus 3, which is 6. Okay, so if I do -2, you get -2 squared minus 3, which is 1. -1 squared minus 3 is -2. 0 squared minus 3 is -3. 1 squared minus 3 is -2. 2 squared minus 3 is 1, and 3 squared minus 3 is 6. Okay, so at this point you can skip this part, but this sometimes helps where you write the points you should be graphing here. So -2, comma 1, -1. The x value, right? The x value goes here, and then the y value goes here. 2, 0, 3, 1, comma -2, 2, comma 1, and 3, comma 6. Okay, so now we're ready to draw our graph. Okay, so let's draw this. Okay, and it looks like we're going to need to go up to 6 on the y-axis and down to at least -3. So let's 1, 2. Sorry, 1 second. Come on. There you go. 2, 3, 4, 5, 6, 7. Okay, and then we need to go out to 3 on both sides. So 1, 2, 3, 4. I always like to go like 1 or 2 extra, if possible. Okay, and then we can do -1, -2, -3, and -4. Okay, so I got my graph coordinate plane set up. So now we're going to do -3, 6. So that's going to be -3 all the way up to 6. So that'll be about right there. Okay, so then we do -2 and 1. Okay, and then now we do -1, -2, 0, -3, 1, -2, 2, 1, and 3 and 6. Okay, so I've plotted the points. So the next thing you should do is to connect these dots with a smooth curve here. Okay, so that's essentially that's kind of like a guess of what the graph looks like. So now, that's all right. So let me outline the steps here for kind of graphing a table. And the thing is, or graphing a function. So here, the thing is the more of these x points you put in between, like the smaller the difference in between the 2 points. So if I would add like -2.5, -1.5, -0.5, if I add more points here, the better this guess is going to be. Okay, but you're never going to be perfect. Okay, so step 1. So here, maybe I should say sketching a graph. 1. You want to make a table. Sorry, hey, kitty cat. Okay, make your table, and then, so, that's x, y equals, and x comma y. Alright, 2, you want to plot the ordered pairs. X comma y, and then last, connect the dots. Okay. So there's one problem with this though. Is, for example, if I were to have taken, it happens with this step 3. So what happens if instead of this nice this certain path that I chose to connect the dots with, there's infinitely many of these that you can do, right? I could have done, well, that one wouldn't be. Here we go. You could do something like this. And that would still work. But that's not, so that still connects all the dots, but we know for a fact that that's not what x squared minus 3 looks like. You can graph it in your calculator. But so there's infinitely many ways you can draw a line connecting those dots. So that's the downfall of this method. For example, or for another example, you could have had, you know, if you had a function like, if you had one that was, you could have 3 similar plots here. So you could have had like a dot here, here, and here, and draw the same picture, or try to, on all 3 of these plots here. Okay, so one could be this obvious parabola, and I did not draw that one very well here. Okay, another one you could, with the same dots, it could be that function, or you could have had this line. See, all those connect those dots. So there's a problem with the method. But usually if you do the table method, you can get a pretty good idea of what your graph is supposed to look like. And if you're unsure if it's correct or not, just add more points in your interval. Right? So when I say adding more points, I don't mean adding, here, let's go back to the, that does not mean you should add more points to, like, I'm saying you should make the space in between your points smaller. So here I'm adding 1 every time. If you want to get a more accurate graph, instead of adding 1, do 0.5 or do 0.25, and then you'll get a more accurate graph. Okay. Alright, so now let's talk about intercepts. So okay, so there's x-intercepts are when the, hi kitty cat, hi, when the graph crosses the x-axis. And y-intercepts are the same thing, but when the graph crosses, oh sorry, this, yeah, the y-axis. Okay, so now think about this a little bit though. So you might, so the ordered pair that intercept would be, so if it crosses the x-axis, remember, is this horizontal line here. So it's not, the x-intercepts come in the form, they have an x-coordinate, but their y-coordinate is 0, right? Because this is the y, if this is the y number line here, then the x-intercepts are going to happen on this line right here, or when y equals 0. And similarly, the y-intercepts are going to take this form, 0, comma b. Okay, so finding x set y equal to 0. Solve for x. Okay, so I should put an S here because there could be multiple. Set x equal to 0, solve for y. Right, that makes sense because if, let's see if I can, there we go, that's a little better. Alright, maybe. So if we want to find the x-intercepts, we should set y equal to 0 and then solve for the values of x here, and vice versa. So let's do an example. So find the x and y intercepts of the equation y equals x squared minus x minus 2. So this is a helpful tool for graphing functions, to know where the intercepts are. Okay. So first we'll find the x-intercepts. Okay, so we got to set y equal to 0, solve for x. Okay, so if we do that, we get 0 equals x squared minus x minus 2. Okay, so now if we solve for x, we can do this by factoring, right? So this is something we learned last section. So we already have it 0 on one side, x, so we need two numbers that multiply to -2 but add up to -1. So I would do -2 and +1. Okay, so that means that, either x minus 2 equals 0 or x plus 2 equals 0. This one says that x is equal to 2, and this one says that x is equal to -1. So these are your two x-intercepts. Okay, so now let's try the y-intercepts. Y. Okay, so the y-intercepts, remember it's the same process, except now instead of setting y equal to 0, we're going to set x equal to 0 and solve for y. So we have y equals 0 squared minus 0 minus 2. So this one's actually a little bit easier. So this is just y equals -2, and that's our y-intercept. Okay. Alright. Let's do another one of those. Okay, so find the x and y intercepts of y equals 2x squared plus 3x minus 2. Okay, so x-intercepts. Okay, so again, we set 0 equal to 2x squared plus 3x minus 2. So this is something we need to factor. So the problem is, remember, this time our coefficient here, this now becomes solving for x, but remember how we do this. If the coefficient in front of the x squared is not equal to 0, we look for factors of a times c. So we need to look for factors of of 2 times -2. The first and last, a times c. That add up to 3. Okay, so let's see. So I would probably do positive. Oh, they add up to 3. Okay, positive 4 and negative 1, right? Negative 1 times 4 is negative 4, but multiplied by 3 is, or I mean, sorry, adding them up together, you get positive 3. Okay, so now we have to rewrite this. So we can do a grouping, right? 2x squared. So we're going to probably do plus 4x minus x minus 2. Okay, it's the same thing. Instead of 3x, though, I'm writing 4x minus x. It's still 3x if you simplify it. Okay, so now I'm going to group them together. So 2x squared plus 4x. Okay, and then plus negative x minus 2. Alright, so in this group I have 2 in both terms. I can factor out a 2 and an x. So you get 0 equals 2x times x plus 2. Okay, in this group I can factor out a negative 1 from both. So it's minus x plus 2. Alright, so now I've got an x plus 2 in both terms, and I can factor that out. So I get 0 equals 2x minus 1 times x plus 2. And there you go. Those are your two x-intercepts once we solve for these. So we have 2x minus 1 equals 0 and x plus 2 equals 0. Okay, so this one's going to be 2x equals positive 1 by adding 1 to both sides, and then you get x is equal to 1/2. Right, okay, so then this one is a bit easier. It's just x is equal to negative 2 after subtracting 2 from both sides. So there's your two x-intercepts right there. Right, so those are the points on the graph. The x-intercepts are, this one's negative 2 comma 0 and 1/2 comma 0. Alright, so then now let's look for the y-intercept. Okay, so that's where we set x equal to 0. Y equals 2 times 0 squared plus 3 times 0 minus 2. So this is just y equals negative 2. Okay, so that would be somewhere, this point, all three of these points are on the graph, 0 comma negative 2. Okay, so that's how you find x and y intercepts. Alright, next topic. We're going to talk about symmetry. So some equations have symmetry. Okay, so what does that mean? It means that if you take one side of it and flip it over a certain line, it's just a copy. Okay, so for example, the line y, or the equation y equals x squared. Let's draw this over here. That's, so if I have 1, 2, 3, 1, negative 1. This looks something like that's not right. Oopsie, sorry. Okay, so that's going to be more like that. This one is symmetric about the y-axis because if I flip this, if I take this side over here and flip it over, it's just a copy. It's symmetric. It's like looking in a mirror. Okay, you can also have graphs that are symmetric about the x-axis, And then any other, you can actually have them that are symmetric about any other line. But we're going to focus on graphs that are symmetric about the y-axis and graphs that are symmetric about the x-axis, and then graphs that are symmetric about the origin. So this kind of dotted line right there. Okay, and there's three ways. For each of those you can check if there's symmetry. Okay, so let's learn how to do that. Okay, so I'll just make a little table. So some symmetry. Okay, so y-axis test. Okay, so for y-axis symmetry, replace x with negative x. If you get the same equation, it is symmetric on y-axis. Okay, so for example, that one that I did, that example y equals x squared, the one that I drew right here, y equals x squared. So that one, so if I replaced x with negative x in that equation, well, that's the same thing as y equals negative 1 squared times x squared, which is just equal to x squared. So that is, in fact, symmetric about the y-axis. Okay? Alright, so what about the other two that I was talking about? So x-axis. So this one is where you do the same thing here, but you replace y with negative y. If you get the same, it is symmetric on the y-axis. Okay, and last but not least, origin. This is where you replace x with negative x and y with negative y. My handwriting is so bad. Okay, negative y. If you get the same equation, it is symmetric It is symmetric about the origin. Okay, so let's do some examples. So, okay, so determine, and you can certainly have a function that's all three of these. Like, it doesn't have to be exclusive, right? Like, you could have one that's symmetric about both x and y. or all three, like I said, or just one. Determine whether, I'm sorry, the equation y equals 1 over x squared plus 5 is symmetric about the y-axis. Okay. So now we look at our, if we want to see if it's symmetric about the y-axis, we take our equation and replace x with negative x and see if we get the same thing. Okay, so to do that we get y equals 1 over negative x squared plus 5. Okay, a key mistake here though is make sure that you're not writing it as, make sure you're not putting it as, right, you don't want to write this as negative x squared, because you didn't replace x with negative x, you just put a negative in front of the x squared. So you want to make sure that everywhere you see an x, you put negative x. So that negative needs to actually be squared too. So this is 1 over. So remember, you can, if you have two numbers multiplied together to the same power, you can distribute that power. So it's 1 over x squared plus 5. So it is, in fact, symmetric, right? These two are the same. Okay, so it's symmetric about the y-axis. Okay, let's do another one. Check if x squared minus, alright. Okay, sorry about that. So check if y squared, x squared minus y squared is equal to 1. Okay. Is symmetric. We'll do around y-axis, x-axis, or the origin. It's not a question, it's just a statement. There's telling you to do it. Okay, so for the y-axis, replace x with negative x. Okay, so we get negative x squared minus y squared equals 1. Okay, so that's the same thing as, right? Same as this example. Negative x squared is the same thing as x squared, so it's x squared minus y squared equals 1. So it is symmetric about the y-axis. Okay. Alright, so now let's try the x-axis. So the x-axis, remember, we're going to replace x-axis, x squared minus negative y squared equals 1. Okay, so that's the same thing as x squared minus positive y squared equals 1. So it is symmetric about the x-axis. So now, but what about the origin? So we need negative x squared minus negative y squared equals 1. Well, this is the same thing as x squared minus y squared equals 1, so it is in fact symmetric about all three. So there you go. There's an example that's symmetric about all three. So if you want to see one that's not, where this doesn't work out, try the last example that I did, y equals 1 over x squared plus 5. Check if it's symmetric about the y-axis. It's not. Or it's not also not symmetric about the origin. Okay. Alright, so we learned how to do symmetry. So now so the nice thing about symmetry is if you do get a equation that is symmetric about one of these axes, you only have to graph half of the graph, because once you graph half of it, you know that it's symmetric, so you can just copy it on the other side. Right? So let's try that. So we'll do the next example. Use symmetry to sketch the graph. Oops, that's a little close. The graph of y equals 4x minus x cubed. Okay, so they just say use symmetry, so I don't know, does that mean I should use the symmetry, y-axis symmetry, x-axis symmetry, or origin? So we actually need to check for all three. So first step is to check what kind of symmetry. So we'll do y-axis first, right? So y-axis, you have to replace x with negative x. Okay, so I've done that now. So let's see if we can make this look like the original. So we get y equals, this is now going to be negative 4x minus, so if negative 1 squared is positive 1, negative 1 times negative 1 times negative 1, or negative 1 cubed, is actually negative 1. So this is now plus x cubed. So we can't get this does not look like, not symmetric. It's not the original equation, right? It's actually like a negative here and a plus there. So that doesn't work. Okay, what about the x-axis? Okay, so that's where we replace y with negative y. And this one's actually pretty clear that it's not symmetric, because instead of a positive y here, we get the negative y. Okay, well, what about the origin? So if they say to use symmetry to graph this function, and it's not symmetric about the x or the y or x-axis, then you could take a pretty good educated guess that it's going to be symmetric about the origin. But let's just check to make sure. So we get negative y equals 4 times negative x minus negative x cubed. Okay, so this is now negative y equals negative 4x, remember, plus x cubed for the same reason it was here. So this doesn't look symmetric at first, but what happens if we divide both sides by negative 1? Well, then this turns into positive y, and then dividing by negative 1 is also the same thing as multiplying by negative 1. Okay, so this becomes positive 4x minus x cubed. So it is symmetric about the origin. Okay. So that's like the first step, is to figure out what kind of symmetry you have. So the next step is to do what we did in that first example and do a table, make a table. Okay, so the key here though is you use only positive values for x. Right, and the reason I'm doing that is because it's symmetric about the origin. So once I have my, if I only use positive values for x, and I look at this here, I'll draw the graph up here just so I don't get in the way. Right, so if I only use positive values for x, I'm going to get a bunch of dots. I don't know, I'm just guessing where these dots are going to go here. So let's say that the graph over here looks something like this. Right? So then I know since it's symmetric about the origin, if I have this point x and y here, it's the same thing as negative x and negative y. Or you can kind of draw a line here that gives you that point. And same with this point. And then same with this point here. It's going to be symmetric, so you only have to draw that 1/2. And then you can use symmetry to copy it. Okay? So let's try it. So if I make my table here, alright, so x and y equals 4x minus x cubed. So let's do 0, 0.5, 1, 1.5. Okay, and 2. And then 2.5. Alright, so if I put 0 into this equation, you get a 0 back. And I'm just going to, you can check and make sure these are right, but I'm just going to give you the values here. 3, 2.6, 25, 0, and negative 5.625. Right. So those are the values that we want to look for. Not look for. Those are the values that we are going to graph on our graph. Okay. So next we plot these values. Okay. So we're gonna go ahead and draw a graph. So I did this in intervals of 0.5, so let's see if I can get this here. So 0.5, 1, 1.5, 2, and 2.5. Okay, so 0. So here, let me put the table back up. So 0 is at 0. We have 0.5 goes up to like, oh, I got to draw the y. 1, 2, 3, 4. Yeah. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6. Negative 6. 5, 4, -3, -2, -1. 0, 1, 2, 3, 4, and 5. Sorry that took so long. Alright, so now we have a 0, 0. We've got a 0.5 and a 1.87, so that's like right below 2. Okay. Then we got a 1, and the 1 gets graphed to 3. Okay, the 1 gets graphed to 3. Then 1.5 gets graphed to 2.625. So that's like right just above 2.5, right there maybe. And then 2 is 0. And we have 2.5 goes all the way down here to negative 5.625. So let's see, maybe right there. So then we can, just like in that first example we did today, we go ahead and connect these dots in the way that we think the graph looks like. So that's what we think our graph looks like here. Okay, so now, finally, we can use our symmetry, and we know it's symmetric about the origin. So any point you draw on this side, when it's symmetric about the origin, you can draw a little line. So for example, on this point, the line, or 0.5 and 2, let's see, now if I draw negative 0.5, negative 1, negative 1.5, negative 2, and negative 2.5. So I have 0.5 and 0.5 and 1.87. So since it's symmetric about the origin, then if 0.5 and 1.85 is 1.875, if x and y are on there, then so is negative x and negative y. That's what symmetric about the origin means, right? If it were symmetric about the y-axis, then then x and y is on there, then so is negative x and positive y. Okay? So, and similarly, if it was symmetric about the x-axis, then x and y would be on there, and so would x and negative y. Okay? So you just got to think about kind of what that means, what kind of symmetry you have. So if 0.5, if I have symmetry around the origin, 0.5 and 1.875 are on there, so that means that negative 0.5 and negative 1.875 are on there. So that means negative 0.5 and negative 1.875 are on there. Just above 2. So see, these, you can kind of draw a line here that connects these 2 points. That's the symmetry line. Okay, so same thing. If 1 and 3 are on there, that means that negative 1 and negative 3 are also on there. If 1.5 and 2.625 are on there, then negative 1.5 and negative 2.625 are on there. So maybe right about there. And we can kind of go ahead and fill in the rest. So this one, I actually didn't make the graph big enough going this way to put the last point on there, but it's somewhere like here. Maybe I can, it's like right here. Okay, so now you just fill in the rest. Okay, and that's how we can use symmetry. So, an interesting thing, remember how I said if you wanted to make a better representation of your graph, you make the interval in between your points smaller. So, it's nice when you have symmetry, you can, if I would have just done, instead of 0.51, 1.5, if I would have done 0, 1, 2, and 3, then I would have had a less accurate picture of what this graph looked like on this side. Okay, so then if I wanted a more accurate picture, I go, instead of intervals of 1, I do intervals of a half, which is what we did in this example. And you get a better, more accurate picture on this side. But since we have symmetry, we can just, instead of copying that, we can now copy that more accurate picture over to the others, depending on what type of symmetry you have. So you can use the same amount of points. So I could have done this without knowing I had symmetry, and I could have had 1, 2, 3, 4, 5, 6 times 2 x values to graph if I wanted to go from negative 2.5 to positive 2.5. But since I have symmetry, I only had to graph half of those values, and I could just copy it to the other side. So symmetry when graphing is a nice, useful way to get past half of the work you have to do. Okay. Okay, so the next example is to sketch a graph using symmetry and intercepts. Okay, so they want you to okay, so this is actually a word problem. So okay, so initially, $400 deer are on Leaf's Island. The number y of deer on the island after T years is described by the equation y equals negative t to the fourth plus 96t squared plus 400. Okay. So the first part is they want you to A, sketch a graph. Okay, so the first thing they want you to do is, or to do this, you should first find the intercepts. Okay, so let's find, so here notice that we're not working with y and x anymore, we're working with y and t. So we want to first find, if we want the t intercepts, set y equal to 0. Okay, so we have 0 equals t, negative t to the fourth plus 96 t squared plus 400. Okay, so there's a, so we notice that this number here is not a 1. It's not a 1. So this takes the form of, it's a quadratic equation, or it takes the form of a quadratic equation, except, so we're going to do a little bit of a substitution here. We're going to do u, so you can do a substitution with u equals t squared. So if u equals t squared. Okay. So then we get a 0 equals negative u squared plus 96u plus 400. See, now we took this here and made it into a quadratic equation, which we know how to solve. Okay, so the problem now that we run into is that, again, we have a our number here is not 1, it's negative 1. But we can fix this one easier, because if we divide both sides by a negative 1, or multiply both sides by a negative 1, well, 0 divided by any number is still 0, so we get 0 equals u squared, now minus 96u plus minus 400. Aha, okay. So now we need two numbers. So we have u times u plus or minus something equals 0. So we need those two numbers that multiply to 400, but negative 400, but add up to negative 96. So that one might take a little while to think about. But negative 400, you could do 1 times 1 and 400, those are factors, 2 and 200, 4 and 100. So wait a second, 4 and 100, if I did positive 100 and negative 4, that would work. So if I do plus, so plus 100, wait a sec, give me 1 second. No, we want a negative 96, right? Negative 96. So we want a plus 4 and a minus 100. Okay, so we factored it. So now let's put our u back in here. So this is the same thing as t squared plus 4 times t squared minus 100 equals 0. So you can check if these two things mean the same thing. So when I say mean the same thing, when you multiply this out, you're going to get positive t to the fourth minus 96t squared minus 400 to check if you wanted to multiply it out. But then you have it equal to 0, so you can multiply both sides by -1 and get right back to where you are here. Okay, so now we have a t squared plus 4, which this is irreducible. This has no, this one has no real roots. But this one is reducible. It's a squared minus b squared, where b is 10. So this we can rewrite as t squared plus 4 times t minus 10 times t plus 10 is 0. Okay. So this one, t squared plus 4, so we check if all three, t squared plus 4 equals 0. Well, this says t squared is equal to -4. And we can't solve for t here because if we take the square root of both sides, we'll be taking a square root of a negative number. So that one has no real roots. So what about t minus 10 equals 0? Well, that says that t is equal to 10. And t plus 10 equals 0. That says that t is equal to minus 10. So here are your, there are your t-intercepts. Okay, so now let's find the y-intercept. So the y-intercept is a little easier, right? So you just set t equal to 0 in this equation here, right? So we get y is equal to -0 to the 4th power plus 96 times 0 squared plus 400. Okay, so that just says that y-intercept is 400. Okay, so we've got the two intercepts. That was, remember, the example says sketch a graph using symmetry and intercepts. Okay, so now we've got the intercepts, so now we just have to see what kind of symmetry do we have. Okay, so should we check symmetry about y-axis? So we're going to replace t with -t. Alright, so if we do that, we get y equals -t to the 4th plus 96 times -t squared plus 400. Okay, so this is y equals -1 to the 4th power. -1 to an even power is just positive, so we get -t to the 4th plus 96t squared plus 400. So it's the same thing. So it is symmetric about y-axis. All right. So it turns out that it's not. So let's check the t-axis. It turns out that it's not symmetric around any other axis. When we do the t-axis, we do replace y with -y, and we can already see that that's not going to be symmetric because we have -t to the 4th plus 96 t squared plus 400. So if we divide this -1 out here, we're going to get all these signs are going to change and we don't have the original equation. So that one's a no-go. Okay, origin. So the origin, if we get -y equals, so if we replace t with -t, we already know that it's going to look like -t to the 4th plus 96 t squared plus 400. And for the same reason that it's not, if I divide out this -1 here, it's not the same. So we have y-axis symmetry. So now we're gonna sketch the graph. So we get or make a table too. So we can make a table of just the positive values because we have symmetry around the y-axis, positive t values. So let's do some nice values for t here. So t, and we have y equals negative t to the fourth plus 96 t squared plus 400. Okay, and then we can make our little t comma y order pair chart. So if I do 0, 1, 5, 7, 9, don't know why they're picking these numbers, but 10 and 11, then, right, I already know this first one, right? This is just this one is the y-intercept, because it's when t is equal to 0. So that one we figured out, it was, what was the y-intercept? 400. Okay, so this is 400. So this is 0, comma 400. So that makes sense, right? In our problem it said, initially there are 400 deer on, not deers, sorry, 400 deer on Leif's Island. So when time is equal to 0, we should have 400 deer. Okay, so I'm just going to fill in the rest of these values here. You can calculate these or put them into your calculator. 2175, 2703, 1615, and okay, sorry, you're not being able to see this. So these numbers all are just by plugging in. All these numbers here, you just plug in the t value into this equation, but we know that 10 is a t-intercept. So, right, from solving it at the beginning, we got that t equals 10 means that y equals 0. That's how we set y equal to 0 here, and we solved it so that t equals 10. So t equal to 10 means that y is equal to 0. T-intercept. T-intercept. Okay, and at 11, we're going to get negative 2,625 deer. Okay, so this one's going to be 1, 495, 5, 2175, 7, 2703, 9, 1615, and 10, 0, and 11, negative 265. Okay, so we've got our table. Okay, so now we make our graph. So 3,000. So I need to go 500, 1,000, 150, 2,000, and 25. Okay, this is going to be a little bit messy here, but so now if I do 0, 2, 4, 6, 8, 10, 12. So this is t and this is y. Or time in years versus... Sorry, you can't see this. That's my fault. Okay, so I've made my graph here. So t in years and population of deer. Okay, so we're going to fill in our graph based on our table here. So our first point is 0, 400, so that'll go right about here. And then we have a 1, so 1, 495, that's going to go right almost to 500. And then we have a 5 that goes up to 2175, so that's right about there. And then we have 7, which goes up to 2703, so 2703, that's almost in the middle, not quite. 1, 6, so at 9 it's 1650. 15. So it's a little lower, maybe right there. And then at 10 we have 0, and then at 12 we've got some very negative number here. Okay, so we're going to connect these. Right. Okay, so now we can use our symmetry, and we know that the graph is going to be symmetric on the y-axis. So, right, if, for example, if 5 and 2,175 are on it, then it's symmetrical with the y-axis. So negative 5 and positive 2,175 is also going to be on it. Okay, so that's our graph. So now, think about it though. You can't really have a negative time, so we actually don't need this side of the graph, right? Negative time. And you don't, let's see, you can't have negative deer either, so we're going to get rid of this part too. Okay, so this is really the actually only part we care about right here. So finally, they also ask you the question. So this was the original question, the original part A was to sketch the graph using symmetry and intercepts, and we did that. And then the second question is, when do deer become, well, there's a part B, and that says adjust your graph so that it to get rid of negative deer and negative time. Okay, and then part C asks, when do the deers become extinct on leaf? So I would say after 10 years, because at 10 years there are 0 deer. Okay, so that would answer that question. Alright, so the last thing I want to talk about today are circles and semicircles. Circles and semicircles. Okay, so every circle has the following equation: x minus h squared plus y minus k squared is equal to the radius squared. Okay, so this is, r is the radius, and the point h comma k is the circle center. Okay, so if I were to draw a picture, of a circle, I'll do my best. Okay, so this would be h, k, and this distance is r. All right. So here, the first example is to find the equation. This by the way is called standard form. Find the equation of the circle with center 7, negative 3 that passes through the point (5, negative 2). All right, so they already actually gave us two really important pieces of information here. They gave us the coordinates of the center. So we know that h is going to be 7 and negative 3 is going to be k. So let's write that. So we got x minus 7 squared plus y minus negative 3 squared is equal to the radius squared. That's something that we don't know yet, but we're going to use this other piece of information to find the radius eventually. Okay, so now we have x minus 7. We don't have to change that. This one I'm going to simplify to y plus 3 squared is the radius squared. So we've got this left-hand side of our equation ready. So now how do we use this other piece of information? Well, if the point 5 comma negative 2 has to lie on the circle, then if we plug in 5 and negative 2 in for x and y, we'll get our radius. Okay, so this is 5 minus 7 squared plus negative 2 plus 3 squared equals the radius squared. Okay, so this 5 minus 7 is negative 2 squared plus negative 2 plus 3 is 1 squared equals the radius squared. So this is 4 plus 1, so 5 equals the radius squared. Okay, so that means that the square root of 5 is our radius. But remember, we want to write the radius squared in our equation. So now back to the equation, we would have x minus 7 squared plus y plus 3 squared is equal to 5. So that's how you'd, using these two pieces of information, that's how you would write the equation of the circle in standard form. Okay, so now let's do another example here, as we're running to the end of class here pretty soon. Alright, so graph a circle. Graph x squared plus y squared equals 1 and x plus 2 squared plus y minus 3 squared equals 25. Okay, so I need another page. Okay. Alright. Okay, so now for the, I'm going to draw them both on the same coordinate plane. You can definitely draw them on separate ones too, but let's just do it this way. So for the first one, so if I label this 1, 1, negative 1, and negative 1, so this is x and y. So in this first one, I have x minus 0 squared plus y minus 0 squared. So x minus 0 squared plus y, minus 0 squared equals 1 squared. So that means that our radius is 1 and our center is 0, 0. So our center is the point 0, 0, and our radius is 1, so we have our circle. Okay, now for the second one, we've got, let's rewrite this a little bit. So we've got x actually minus negative 2 squared plus y minus 3 squared is equal to 5 squared. So the reason I did that is because I want to see where the center is. So my center is going to be at negative 2 and 3. So if I go over here to negative 2 and up to 3, that's where the circle center for the second circle is going to be. And then it has a radius of 5. So this graph is actually going to be way too small for 5, because I need to go all the way up to 8. So maybe I can finagle something here. 6, 7, 8. Okay, so then I need to go 1, 2, 3, 4, down to -2. And then this side needs to go out to -3, -4, -5, -6, -7. Right, because I need to go 5 out in each direction. So 1, 2, 3, 4, and 5. Okay, so our second circle is going to look kind of like so all the way down to -2. This is a horrible drawing, I'm so sorry. So then go up to 3 and there. So those are our two circles, unfortunately. I have to apologize for my poor drawing skills. Okay, so that's how you would graph circles, is you need to put them in standard form, which they already were, and then graph them. Okay, so a semicircle is semicircle, talk about this for a second. Is the same thing. We're going to look at, so let's look at x minus h squared. Oh, you guys can't see this again. So x minus h squared plus y minus k squared equals r squared. So if we write this out, there's going to be some sort of here, actually, let's just take h and k equal to 0. So this is the circle centered at the origin with some radius. Okay, so this is going to be x squared plus y squared equals r squared. So if we want to solve this for y, like we would in chapter 1, sometimes they ask you to solve for y. You get y squared equals r squared minus x squared. And now we could get y equals plus or minus the square root of r squared minus x squared. Okay, so the semicircles, or you could similarly, you could have also gotten x squared equals, so plus x squared equals x equals plus or minus the square root of r squared minus y squared. Okay, so these are four, right? You have a plus or minus on each side. 4 different semicircles here. So if we draw 2 coordinate planes to graph all these, we would have had, so y equals plus the square root of r squared minus x squared. So y equals positive square root of r squared minus x squared. You can just graph that normally how we've been learning to graph it. And then the bottom semicircle is y equals negative square root of r squared minus x squared. And then similarly with this side, here we have, this one is x equals positive root r squared minus y squared. And then this side, this semicircle is x equals negative root r squared minus y squared. Okay, so there are no examples to go with the semicircles, but semicircles are kind of written in the same exact standard form here, except they just are expressed, you solve it for y. So a general circle is going to be written in this form, but a semicircle is when you solve for one of the variables. Okay, and specify which positive or negative, which square root you're using. Okay, so finally we have we've got one more example. So this one is where they want you to find the center and radius of the circle given by the equation x squared plus y squared minus 6x plus 8y plus 10 equals 0. Okay, so they've given us something that's in a general form, and they want us to convert it into standard form this way. Okay, so this is all it's going to take is a little bit of what we already learned. So some factoring and some completing the square. Okay, so first we're going to group the two x terms and the two y terms together. So this is going to be the same thing as x squared minus 6x plus y squared plus 8y, and then we're going to move the 10 over to the other side. So all I did here is change the order that I added these terms in and then subtract the 10 from both sides. Okay, so now we need to complete the square. Okay, so noting that if I do x squared minus 6x, I need to think of, so if I have negative 3 plus negative 3, that adds up to negative 6, so I need to add so negative 3 plus negative 3 adds up to negative 6, but if I multiply them together, you get a positive 9 here. So I'm going to add 9 to both sides. So this, I'm going to move the equal sign over here. Right? If I added 9 to this side, then I have to add 9 also to that side. Okay, so now if I want to complete the square here, if I add 4 to 4, 4 plus 4, right, you want to look at this middle number here, and it's, you want to add the same number to it to get to that number, right? So this one I did negative 3 and negative 3. Here I'm going to do positive 4 and positive 4. But 4 times 4 is 16. So y squared plus 8y plus 16. Okay, so if I add 16 to this side, I've got to add it to this side. So essentially I'm adding 25 to this side and adding 25 to this side in this step. Okay, so now though, this is if I wanted to factor this, right, we set it up so that this is going to be x minus 3 squared, right? And this one's going to be y plus 4 squared equals 15. So then the center, we've got it in standard form. So the center is it's 3, and right, this is actually y minus negative 4, so you got to be careful. So it's 3 negative 4 with a radius root 15, because this is r squared, so then r is the square root of 15. Okay, alright, that's all I wanted to talk about today. Please email me with any questions, and I'll have office hours at 3. Monday, Tuesday, Wednesday, Thursday.